Okay, question 14 says that the angle of elevation to the bottom of a transmission tower on a hill from an observer 1.8 kilometers away from the base of the hill is 5 degrees. Okay, so there's heaps of information in that first sentence, so let's break it down a little bit. The angle of elevation to the bottom of a transmission tower on a hill. So there's a transmission tower on a hill. So first of all, I'm going to draw a hill. And on top of it, I'm going to draw a transmission tower. So here's my transmission tower. There's a little aerial on top. Okay, so that's out of my mind now. And it tells us the angle of elevation to the bottom of the tower. So the bottom of the tower is going to be here. It's the top of the hill. The bottom of the tower, top of the hill, same thing. And the angle of elevation from an observer 1.8 kilometers away from the base of the hill. Okay, so the base of the hill is here. And we've got an observer, so a person, standing 1.8 kilometers away from the base of the hill. So we can draw that information in. We've got an observer here, and this distance from the observer to the base of the hill is 1.8 kilometers. And now it says the angle of elevation to the bottom of the transmission tower from the observer is 5 degrees. Okay, so that makes more sense. We broke the question down, we drew all the different parts, and now we can look at the angle of elevation. So remember, an angle of elevation starts at the horizontal, and we've already got our horizontal line here. This is just a distance along the ground, so that has to be a horizontal line. And it moves upwards. Angle of elevation elevates up from the horizontal, okay? And it goes from the horizontal to the line of sight, which is the line between the two objects. And in our case, it's going to be the observer and the base of the transmission tower, the bottom of the transmission tower. So we're going to draw in a line to represent that line of sight there. So you can see that that sort of creates a right angle triangle. I've drawn my base of the hill here, but we could also say that the base of the hill is here. It depends whereabouts he's standing around the hill. So let's just draw in that this creates a little triangle. This is a vertical height of the hill, and along the bottom here we've got a horizontal distance. So we know that that's going to be a right angle. So we've created a little right angle triangle. And they told us that the angle of elevation, so the angle from the horizontal up to the line of sight here, that's 5 degrees. So we can put that information in as well. And then it says the angle of elevation to the top of the tower from the observer. So this time we're going from the horizontal even further up. We're elevating past the bottom of the tower up to the top of the tower up here. So we need to draw in a new line of sight. So this is our new line of sight. Now this angle of elevation is 6.8 degrees. Remember, the angle of elevation is always measured from the horizontal. So this is going to be a larger angle because they're looking further up. So it's gone all the way up to there, so the angle's larger. If the distance from the observer to the base of the hill is 1.8 kilometers, well, we know that already, we've already put that in. Find the height of the tower to the nearest meter. Okay, so we're interested in finding this height here, just of the tower. We're not interested in the hill, we just want to know the height of the tower. But this height of the tower, it's not a side in a right angle triangle, so we can't find it straight away. But we can use both of these right angle triangles that we created. We've got this large right angle triangle, and we've got this smaller right angle triangle here. We can use both of those to find some heights over here. We can use the larger one to find the total height, because that will be a side in the large right angle triangle. So we can find the total height here of the hill and the tower. That will be this length here. And we can use the smaller right angle triangle here to find the height of the hill. So if we know the height of the hill and we know the height of the hill and the tower, all we need to do is subtract the height of the hill from this total height and we'll be left with the height of the tower. So if we can find this height here, this height of the hill, we'll call it x, and we can find this total height, let's call that y, then we're laughing. We can find the height of the tower quite easily. We just need to subtract x from y and we'll be left with the height of the tower here. So how are we going to do that? Well, we need to use our two right angle triangles. So maybe we'll draw the triangle out again just because it's getting a little messy here. So I'll draw out my small triangle first. Now remember, this small triangle has an angle of 5 degrees and this distance along the bottom is 1.8 kilometers. However, the question says if the distance from the observer to the base of the hill is 1.8 kilometers, find the height of the tower to the nearest meter. So because it wants the answer in meters, I'm going to convert this to meters and just get that out of the way because we're going to be working in kilometers if we keep it as 1.8. So 1.8 kilometers, that's 1,800 meters. So I'm just converting to meters. I haven't actually changed any distances. And we've got our right angle here. This is the height that we're trying to find here, x. So which trig ratio are we going to use, SOHCAHTOA or TOA? Well, I can see that this is my given angle, 5 degrees. So I'm going to be using the side opposite my angle and this side here that's adjacent to my angle. So I'm using tan again, and pretty much all of these questions use tan. Tan of theta equals O over A, opposite over adjacent. Our angle theta is 5 degrees. Our opposite is x. And our adjacent is 1,800 meters. We don't have to write meters, but... Okay, so now we just need to solve for x. We've got an equation here with only one unknown, which is great. So let's just perform inverse operations to isolate x. On the left-hand side, we've got 1,800 times tan of 5. And on the right-hand side, we've just got x because these cancel out. So we know our height is just going to be whatever this expression turns out to be. This is just some number. 1,800 times tan times 5. Oh, sorry, of 5, not times 5. Tan of 5 gives us x equals 157.48 meters. Okay, so our height of our hill is 157.48 meters. We know x, our height of our hill there. And now we need to find y, which is our total height of the hill and the tower. So let's draw out another triangle, our larger triangle this time. So we've got another right angle triangle. This time our angle is 6.8 degrees here. Got our right angle. Our distance is still going to be 1,800 meters along the bottom here. And this time we're interested in finding the total height y here, which is this larger side in our larger triangle. And we're using our opposite side and our adjacent side. So we're using tan again. Tan of an angle is equal to opposite over adjacent. And our angle is 6.8. Our opposite is y. We don't know what it is yet. And our adjacent is 1,800 meters. We just need to solve for y now. We've only got one unknown. So we use inverse operations to isolate y. On the left-hand side, we end up with 1,800 times tan, 6.8. And on the right-hand side, we end up with y, which is our height. That's what we're trying to find. It's isolated now. So we just need to put this expression into the calculator. It just comes out as a number. Okay, so we know that y is equal to 214.64 meters. Okay, so we've got X and we've got Y. We've got X is 157.48 meters and Y is 214.64 meters. So if we subtract X from Y, we'll end up with our height of our transmission tower here. So let's do that. 214.64 minus 157.48 gives us a height. So height of our actual transmission tower here, height is 57 meters to the nearest meter. I think the textbook says 58 meters, but that's just because of rounding off. I think 57 is actually a more accurate answer. So you might get your answer slightly off, and it's just because of rounding that you did throughout the question.